Dear students, in this session, we shall discuss about the what is a phasor diagram and how to write the phasor diagram in a resistor and capacitor and inductor. So phasor diagram is nothing but a diagram is drawn for current or voltage vectors with phase are called a phasor diagram. In simply we say as the diagram is drawn for rotating vectors. Rotating vectors are called a phasor diagram. So current is a rotating vector or voltage is a rotating vector. Such a rotating vector represented by a diagram are called a phasor diagram. Let's see how changes the current and voltage. So this is a phasor. Phasor, this is nothing but amplitude. The projection of vector, let's see up here. The vector is rotated along the with the angular velocity omega. So at any time, what is the instantaneous voltage? Vm of sine omega t, sine of plus of omega t plus of phi. So now draw the projection of a vector. Draw a projection of vector that gives the instantaneous value. If vector rotate 360 degree with the angular velocity omega, it complete one cycle of a sine wave. The diagram shows clearly. It completed a one cycle. So at any instant of time, what is the amplitude of voltage or voltage that gives to the instantaneous voltage? This is a phasor diagram. So now let's see the example to the phasor diagram. So now construct x and y axis. So here positive x axis is nothing but a reference line. So now we shall write the 2 volt instantaneous voltage V1 equals to half a amplitude 5 times of sine omega t plus of 30 degrees nothing but phasor angle, and one more vector V2 of amplitude is a 10 sine of omega t plus 80 degree. So how to draw the phasor for V1 and V2? So now let draw the phasor vector for V1 whose amplitude is pi, and what is the angle made by V1 with the positive x-axis 30 degree. Similarly for V2 vector amplitude is a 10, draw a phasor. So length of the line or vector represents the amplitude or magnitude, and phasor angle is 80 degree with positive x-axis. So in this way we can draw the phasor diagram for different voltages. So let's see one more example. This is nothing but ahead or forward or anti-clockwise rotations. So phasor vectors are always rotated in anti-clockwise direction, means ahead, which are rotated in ahead direction. Similarly, lagging direction. So now let's see the say voltage V1 equals to 10 sine of omega t minus 30 degree, and one more signal, one more vector V2 equals to of a amplitude 5 sine of omega t minus 120 degree lagged. So how to draw the phasors for these two vectors V1 and now let draw the phasor vector for V1 of length 10. 10 is nothing but amplitude. The length of the vector always represents the magnitude or amplitude. 30 degree is nothing but phase. Minus 30 means so lagging by 30 degree. So similarly, draw a vector for V2 whose amplitude is a 5. The length of the vector is represented by 5 and lagging by 120 degree phasor angle. So in this way, we can write the phasor diagram for vectors V1 and V2. So in previous case, we saw leading, both V1 and V2 are leading. In this case, V1 and V2 lagging by what 30 degree, lagging by 120 degree. In previous, so what is a phase difference between V1 and V2? That is 120 degree minus 30 degree equals to 90 degree. Similarly, in previous case, leading case, what is the phase difference between V1 and V2 equals to 80 degree minus of 30 degree equals to 50 degree. So this is a phase difference between two vectors in leading case. So phasor representation in case of a polar form. How to write the polar form? Polar R is nothing but amplitude or magnitude with angle theta. So that is a represent like that only. Vm of phi, Vm of angle phi. So this is a phasor representation of vector. In rectangular form, A plus of JB. Magnitude is modulus of R equals to square root of A square plus B square. So phase pi equals to tan inverse of B divided by A. So in this way, we represent the phase and magnitude in rectangular form. And exponential form. In exponential form, it can be written as Vm into e to the power of j pi. J is a complex factor. Complex factor. So, how phasor relationship for resistors? So, this is the diagram shows to you in a resistor current passed as a high and V is a potential difference. The equation at any instant of time voltage can be written as V of t equals to Vm of sine of omega t plus phi. So Vm is peak value of voltage or amplitude, pi is a phase. So it can simply written as Vm of angle pi. So what is a Vm of angle of phi? That is equals to V only. What is the current through heat? Instantaneous current. I of t equals to Vm of sine omega t plus pi over r. Just divide by above equation by r. R I equals to Vm by r is V by r. Vm sine omega t plus of phi is nothing but V. That is equals to V by r. Or V equals to Vm angle of pi above showed here. So phasor diagram represented as current and voltage having a same phase sine of omega t plus pi. We can represent same direction but amplitude difference. So what is the impedance? Impedance is nothing but voltage divided by current. That is nothing but Z only. Z is equals to R. In case of inductor, so when current I is nothing but passing through the inductor, that can be written I of t equals to Im sin omega t plus of pi. This is instantaneous current. Next, what is instantaneous voltage? So it can be simplified as Im into angle of pi, that is equals to I. VL is equals to L of di by dt. Or differentiate of I, we get sine of omega t plus pi differentiation is nothing but cos of omega t plus of 5 into omega. Or omega L Im sin omega t plus of pi plus 90 degree. Means cos omega t plus of pi can be written in the sine form sine of omega t plus pi plus. These are two are allied angles. So just observe current and voltage equation. Voltage is ahead by 90 degree over the current. So in phasor diagram, green line represents the voltage and red is nothing but a current only. Voltage is a leading by a current over 90 degree. So this equation simplified as omega L e to the power of j phi of by 2 Im L phi. Means phase difference is pi by 2 radian. Or similarly j omega L I is nothing but Im into angle phi. Therefore V is equals to j omega L I. Next, what is the impedance? Impedance is nothing but V divided by I equals to Z. What is a V here? V is equals to j omega L into I over I. In both numerator and denominator get a cancel. I get a cancel. Remaining thing is Z is equals to j omega L. J omega L. This is the impedance to the impedance in a inductor. So it can be reactance XL. XL is a reactance. XL equals to omega L or j omega L. Similarly, what is a phasor relationship for capacitor? In a I be the current through a capacitor, or V is a potential difference at instant of time. It can be written as V of t Vm sin of omega t plus of phi only. Current through a capacitor can be written as C dV by dt. Now we differentiate the V. So what is the differentiation of sine of omega t plus of phi? That is the C omega cos of omega t plus of phi, or omega c Vm. It cos omega t plus pi can be written in sine form as sine of omega t plus pi plus 90 degree. So just observe here, what is the phase between the V of t and I of t, that is a 90 degree. Draw a phasor diagram. So here green line represents the current and red pink line represents the voltage. Current is ahead by 90 degree over the voltage. So in simple form, current can be written as omega c e to the power of j pi by 2 Vm times of angle of pi, or j omega c V. So Vm times of angle phi is nothing but V. This is nothing but current. So what is the impedance? Impedance is equals to voltage divided by current. That is equals to Z. So what is the voltage here? Voltage is nothing but V. Current is equals to J omega C V. We get a cancel. Ultimately we got X is equals to 1 over J omega C. So this is a phasor diagram. So what is a phasor? Phasor is nothing but rotating vector of voltage or current. That is nothing but phasor. So in this way we can draw the phasor diagram. In different cases like a capacitor, inductor and resistor. Thank you.